Okay guys, today let's talk about how to perform an elimination mechanism on a cyclohexane. Now remember, when dealing with elimination, you need to have a couple of prerequisites on the molecule, specifically a strong base, a leaving group, and beta hydrogens that are anti-paraplanar to the leaving group, meaning that they are on opposite stereochemistry. Let's work one out to see what it would look like. So we've got our strong base. It's written over heat to ensure that it acts only as a base and not also as a nucleophile. And we are going to have to translate everything we see on our cyclohexane down to these chairs. Okay, so remember this little acronym here, double D dash down. So that means if it's on a dash bond up here, it must go on a down position here. So starting with carbon 1, we can see that we've got bromine on a dash down position. So Br on the down position here and Br on the down position here. Carbon 6 has got two methyl groups, so Me, 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 and carbon 2 dash down methyl group, Me, Me. Now that we've done that, so remember that this chair is kind of flipping back and forth like a million times a second. It just may spend time in one conformation or the other based on stability. But as far as anti-paraplanarity goes in a cyclohexane, that means that your leaving group must be in an axial position, and so must your beta hydrogens. Okay, so our beta carbon 2 also has a proton. We may as well fill that one in here as well as over on carbon 2. So notice on this right chair, bromine's in an equatorial position. So what that means is when that ring is in the right chair conformation, we're not going to have any elimination at all because the leaving group must be axial as well as the beta hydrogen. So the untrained eye would sometimes make the mistake of being like, okay, here's an alpha, here's a beta, here's a beta. We're expecting a double bond to form between 1 and 6 and 1 and 2. But don't get fooled here. There's no hydrogens coming off of carbon 6, so we will never see a double bond between 1 and 6. We do have a possibility of having one form between 1 and 2. We can confirm that by coming down here to our chair and notice that our bromine is in the axial position as well as our beta hydrogen coming off of carbon 2 also in an axial position. So our final answer would look like this if we draw it back in a cyclohexane form. Double bond between 1 and 2. The methyl group C is now on a stick because it's coming off of an sp2 carbon, and sp2 carbons have trigonoplanar geometry, which means any bond coming off of it must also be as a stick. Our two methyl groups coming off of 6 are still there, unaffected as far as stereochemistry goes, and we can label these 1, 2, C, 3, 4, 5, 6, A, and B, and that is our final E2 answer for this particular problem. If you found this video helpful but need more in-depth explanation and see a lot more practice problems worked out, you can find the full-length version over at orgogo.com. Please like, comment, and subscribe to help our videos find more students like you, and tell a friend. And if you're interested in private tutoring, or if you want a concept explained that you don't see on our YouTube page, shoot me an email at orgogoat@yahoo.com.